In this video, I'm going to be looking at how to convert a binary number to a decimal number. But let's take a little step backwards and consider how we calculate decimal numbers. Well, here's an example of 100, okay, 1 and 2 zeros. And you'll remember from primary school that that means you have different columns for hundreds, tens, and units. Now let's think what that means a little bit. In a decimal system, you have 10 different digits. So you have a 0, a 1, a 2, a 3, a 4, a 5, 6, 7, 8, and 9. So these are the 9 different digits that make up the decimal system. And then they are arranged in columns for units, tens, hundreds, thousands, 10,000s, etc., etc. And if you think about what that actually means, what it means is that that would be 10 to the power of 0. So those are our individual units. The tens are 10 to the power of 1. And the hundreds are 10 to the power of 2. And if we get into thousands, it would be 10 to the power of 3, which is 10 times 10 times 10, a 1 and 3 noughts. 10 times 10, a 1 and 2 zeros, 100. 10 just by itself, and units over here. So this would be units, that would be tens, and that would be hundreds, and that would be thousands. So if we had a 1 here and a 0 and a 0, and we wanted to work out what that meant, you have 0 in the units column, 0 in the tens column, and 1 in the hundreds column. So you've got 100. Fairly simple, yeah? So let's do something similar, but looking at binary numbers. Now, binary means 2, yeah? So there are 2 numbers. The only numbers you have available are a 0 and a 1. And these are used in computers because electricity flows 0 or doesn't flow 1. I can never remember whether it's flow or not flow. It might be the other way around. But electricity is off or it's on. It's flowing or it's not flowing. A 0 or a 1. And the zeros and ones make up any number that you can think of in a computer system. So you would write binary numbers a bit like this. You have 1, 0, 1, 0, 1, 1, 1, for example. So let's do the same as we did with the decimals and try and work out what that actually means. Well, because this is a base 2 system, there are only 2 numbers, it's 2 to the power of 0 in the first column, 2 to the power of 1 in the second column, 2 to the power of 2 in the third, 2 to the power of 3, 2 to the power of 4, my writing is getting absolutely awful, 2 to the power of 5, and 2 to the power of 6. So let's do some calculations there. So 2 to the power of 0, remember, is a unit. 2 to the power of 1 would be 2. 2 to the power of 2 would be 2 times 2, which is 4. 2 to the power of 3 would be 2 times 2 times 2, which would be 8. And you'll notice we're just doubling. 2 to the power of 4, 2 times 2 times 2 times 2, 16. 2 to the power of 5, we can double that, 32, 64. And of course, 2 to the power of 7 would be 128, and then 256, and so on and so forth. So to calculate what all of this means, we're going to add these up. So we're going to take, where there's a 1 here, it means you've got something in that column. So that would be 1 times 1 would be 1. And we're going to add it. You'd think, why are we working from right to left? Well, you think of these are all Arab numerals from the Indo-Arabic number system and is written from right to left. 1 times 2 would be 2. 1 times 4 would be 4. Now that's 0 times 8, so that would be 0 plus. Now we get 1 times 16, so that would be 16. 0 times 32 would be a 0. And 1 times 64 would be 64. Please excuse my bad handwriting. I'm doing it with a mouse. So to work it out in decimal, we would then add these numbers up. So you get 64 plus 16 would be 80. Just double check because I'm not that good at arithmetic. So it would be 76, 80, yeah. 84, 86, 87. I think I got that right. So this 1010111 in binary, base 2, you can write it there, base 2, would be 87 in decimal, base 10. Write out a few of these numbers and see if you can do the same. Work it out from binary to decimal.